Okay, so to solve this problem, the first thing we want to do is get the equation in the proper form so we can verify that it's homogeneous, and then we can go ahead and make the substitution and solve it. So again, the form that we're looking for is m times xy dx plus capital N xy dy is equal to 0. So the first step in this process is to rewrite our y prime as dy dx. And then from there, we want to multiply both sides of the equation through by dx. So that's going to give us a 2y squared minus x squared dx. And now if we bring the term to the other side, we're going to have plus a negative x squared dy is equal to 0. So that first coefficient, again, is our capital M. That second coefficient is our capital N. Now, to verify that an equation is homogeneous, we need to calculate m of tx and ty and simplify it down. So that's going to require us to put a tx and a ty in place of the x's and y's. So for m, that's going to be 2 times ty squared minus tx squared. Using the rules of exponents, that's really 2t squared y squared minus t squared x squared. There's a common t squared we can factor out. Leaves you with 2y squared minus x squared, which is t squared times the original m that we started off with. We can do the same thing now for n of tx and ty. That's going to be negative quantity tx squared, and that's just negative t squared x squared, which is going to be t squared times negative x squared, which is just t squared times our n. So you notice that we get a t squared as a coefficient on both. So we say that we have a degree of 2. Now, what's interesting about all these problems, we actually don't use the degree to solve any of the equations. Instead, we just note it and we move forward with it. So again, the fact that it's degree 2 versus another degree doesn't play a role in how we solve it. So the next step now is to go in and remember that we're going to take y is equal to x times v and substitute this into the original differential equation. So if you take derivatives, we have a y prime, but x times v is a product, so the derivative of the first, which is x, is just 1, times the second, plus the first, which is x, times the derivative of the second, which is v prime. So this is actually v plus x times v prime. So everywhere we see a y prime, we have to replace it with v plus x times v prime. And everywhere that we see a y, it's going to be replaced with x times v. So in the next video, we'll actually go in and substitute these into the original differential equation and simplify it down.